Welcome to Contextual Electronics. My name is Chris Gamble. Today we're going to be going over some footprint stuff and a new feature that I really like in KiCad 5.0 where we get to use some more math. I'm not a huge fan of math, but when I'm making footprints, this is actually really useful. So first things first, let's look at this crazy footprint we're going to be looking at here. This is actually a linear tech footprint. This is the, who cares, the LTC3611, doesn't really matter. But what it's showing is this is a huge module with a bunch of crazy footprint parameters here. And so what we're going to do is we're going to try and just do a little bit of this and showcase the math functions that are now available in KiCad. Now I'm going to ignore this guy up here. This thing's a bit crazy. We're just going to use the lower left pad and use that as an example here. So let's first create a footprint. We'll call this Crazy Town because this is a Crazy Town footprint. And what we're going to do is create our first pad here. Hit escape, get out of that first one. We're going to mouse over, hit E, select the pad. And now what we're going to do is change it from a through hole to an SMD. We're going to make it rectangular, even though it's rounded rectangular, and we could do that with this one. We're going to just do it the normal way. We're going to skip the position. Actually, we'll just zero out the position stuff for now. And then we're going to change the size, and we are in millimeters right now. You should note on the left side here. We're going to change the size to this, what the size is here, 2.4 tall, 2.04 tall by 3.99 wide. 3.99 is first. 2.04. Let's take a look at what that looks like. So that's right there at 0, 0. It might be hard to see the center point here. I know it's in blue. Blue over black is not easy to see, but hopefully it's not. Trust me, it's in the center. So we're mouse over, hit E again, and modify this thing. And what we're going to do now is we're actually going to go and grab the actual coordinates. Now what you see here is the center point of this part is the 0, 0 is right in the center, as it should be. You always want to make your parts so that they have a center point that matches, basically that's going to be used for the pick and place, and it's just good practice to make sure your parts have 0, 0 as the first, as the center of the part. Sometimes people do it on pin 1. I used to do that. I don't do that anymore. That'll mess up your pick and place. All right, so we're gonna. So the thing we see here is it extends down and then it goes to the left. So it's 3.85 off center, and you see that just that slice, whatever that difference is there. Now, in the old days, we would have had to do the math either on paper or I usually just had a calculator open doing the math there. But what we can show now is we can actually do some of this here. So we're gonna do the x first, and we're gonna say so it's 3.85 was that distance. Then we have to take half of the pad off of that, right? So basically we want to take from the edge here, we want to go back by half of the pad. So what would that be? So we can do 3.99 divided by 2, and then that whole quantity is subtracted off 3.85. What I also know is that the left side of the grid coordinate system is going to be negative. So what I'm going to do is make this entire thing minus the entire quantity. If I hit tab, now it shows what that is. If I go back, I can actually go and edit that. And so we got minus 1.855. Okay, great. Now let's do the same thing here. Now we know that we have the, so we have 1.8. So now this is the center point in the y direction. That in our coordinates, the y going down is 0 for some reason. So that's fine. We'll just deal with that. 1.81 to the front of this pad. And then we want to go another half of the pad width, right? So 1.81 plus half of 2.04. So we can do that slightly different one. 1.81 plus 0.5 times 2.04. And we know that from our order of operations stuff that the timesing should happen before the plussing, right? So 2.83 is our thing there. Let's hit OK. All right, so now how do we go in and how do we check this thing? Well, what we can do is we can just go and grab the lower coordinate of this. So we know that from 0, 0, the lower left corner should be 3.85. And if we add these two numbers together, it also is 3.85. That actually is what I figured out after the fact. But 3.85 should be our coordinate in the lower left corner. Let's zoom in here. And if we mouse over it, looks like, if you see down here, 3.85, well, minus 3.85 and 3.85 is our coordinate, so it looks like we did do that right. Now, if we want to, we can go in now and we can make this a rounded corner. We just wanted to grab that one because it's a little bit easier there. Down the corner size now, I don't think they actually spec it. Looks like the rounded corner, so we can just grab a generic, 5% rounded corner. It's really not going to do too much there, but it kind of cuts off the corners a little bit. Okay, so we've got that, and we're good to go. So we would go through and we would definitely refer to all these other things as well. If we look at this footprint, there's a lot of math here. But if you just take it piece by piece, that really helps to do it. A lot of these drawings and tolerancing that they do here, it's it's done from I think this one is actually done pretty well. It's going to vary depending on the vendor that you have and how it, what their style is and how they actually notate these things. I think this one actually, from a math perspective, is actually pretty good. I know that sounds kind of weird, but I think it's actually, this one's not too bad. So if you have any other questions, this is actually a really nice addition to the KiCad 5.0. I really appreciate that the developers put this one in. I think I requested this one at one point. Not that they were listening to me, but there are requests that do go through, and I think that's really nice. So I do recommend that you support the KiCad project. You can do so through CERN. We'll put the link down below. You can donate and support KiCad if you'd like to. If you'd also like to, there's t-shirts that we sell through Contextual Electronics and hats about KiCad, the proceeds of which go to support the project. And finally, if you're interested, in April of 2019, April 26th and 27th in Chicago, there is a conference, and the proceeds of that also are supporting the project. So that's all for now. We can always go over to the forum. That's forum.kicad.info to ask some more questions. That's all for now. Thanks for watching.